Solutions of equations using ordered pairs.
All right, so solutions of equations using ordered pairs. The first note says see next page. So all of you are going to flip either in your notes to the next page or digitally scroll down to the page break. We have a whole bunch of vocab. We have ordered pair, we have coordinate grid, we have x-axes, we have y-axes, we have, I gotta go to my next page here, we have quadrant, and we have origin. You need to know what all of those things mean if you don't already know what they already mean. Suki, with us here? Also, in your grid or on your coordinate plane, you have labels for everything. I expect you from this point forward to know where the quadrants are, what their values are, x-axis, y-axis, origin. I think you're probably pretty good at those. All of this stuff needs to be tucked away in your brain and pretty easily accessible, like you know it, without having to look. Table of solutions. You have the input, which is what, you guys? How about everybody? The input is what?
X.
The output is what?
Y.
In your ordered pair is the value x, y. X is always first, y is always second, right?
Yeah.
Right. The example here then would be using this equation and these plugins. So this is the equation. These are the plugins to complete the table given to you. Okay, so you're going to be doing a couple of those in your homework assignment. We also know x as the input and y as the everybody.
Output.
So x is what you put in, y is what you get out. Say that, please. X is what you put in,
X is what you put in.
y is what you get out.
Y is what you get out.
Awesome. Number 3, practice. You've got a couple of equations. You got the ordered pair. You're just proving that they work or they don't work by plugging in. You either prove that they work or they don't work by plugging in. Number 4 is where things get a bit complex. We're calculating sales tax in Minnesota. The base is at 6.5%, even though in most counties and most places it's much higher than that. But the base is 6.5%. We have the formula y equals 1.065x for sales tax. Y represents your cost of an item plus the tax, so that's your output. And x represents the input, how much the item costs. So in our problem down below, we had a $15 purchase. We plugged in, you with me? We plugged in $15 for x, so our input was 15. We multiplied by the sales tax, which is 6.5%, plus we have to make sure we include the 15. That's where the 1 comes from. The 1 represents the 15. The sales tax represents how much we're taxing on that $15. And then we're spitting out the output, which is going to be $15.98. If I were you, and this is not making total sense, I would rewatch what I just said the last 45 seconds several times. Rewatch it, rewatch it, rewatch it. Think about what I'm saying. Input, output. What does the 1 represent? What does the 0.065 represent? You know 6.5% is represented in decimal form as 65 thousandths. And then I think Matt gave us this is really good. Inserting a 1 in front of a percentage or a decimal gives the total value. I'm going to separate these two things here. It gives the total value plus the percentage, or plus whatever the extra is.